Dot product, part 1. Work done by a constant force F in moving an object a distance of d is the product of the force times the distance. Let's bring this discussion up to the level of vectors. If the force is a vector F applied at an angle theta to the direction of motion, the resulting displacement of the object is a vector d. The component of the force F in the direction of motion will be the magnitude of the force times the cosine of the angle between the two vectors. And the work done by the force is the component of the force in the direction of motion multiplied by the distance moved by the object. And this motivates a definition. The product of the magnitudes of two vectors and the cosine of the angle between them is called the dot product. Stating this more generally, given two non-zero vectors u and v in 2 or 3 dimensions, their dot product is the product of their magnitudes times the cosine of theta, where theta is an angle between u and v, and theta will be stated as being between 0 and pi. If one or both of the vectors are the zero vector, then their dot product is 0 and theta is undefined. I want to point out to you that the dot product is a scalar value. The sign of the dot product depends on the magnitude of theta. If theta is between 0 and pi over 2, that dot product will be positive. If theta is between pi over 2 and pi, that dot product will be negative. If theta is 0, then the dot product is the product of their magnitudes. Theta being 0 means they point in the same direction. In fact, the dot product of a vector with itself is the square of its length. On the other hand, if theta is equal to pi over 2, then the two vectors are perpendicular, and their dot product is 0. This brings us to a definition. Two vectors, u and v, are orthogonal if and only if u dot v is equal to 0. So the 0 vector is orthogonal to all vectors. In 2 or 3 dimensions, we use the word orthogonal and perpendicular interchangeably. Now the definition of a dot product is somewhat difficult to work with, and we are very happy to get this great theorem that if you want to know the dot product of two vectors, as long as you know their components, that dot product is very easy to find. Let's find the dot product of u and v. Well, if I write them as components 2, -6, 0, dot 0, 0, 12, the dot product you can see is just 0 plus 0 plus 0. The dot product is 0. Now that implies that the two vectors are orthogonal. And in fact, if we look at a picture of the two vectors, we can see that they are perpendicular to each other. How about these two vectors? Let's find their dot product. This time u dot v is equal to 1. So u dot v is equal to 1, a positive value. So we would expect the angle between the two of them to be between 0 and pi over 2. And in fact, the angle is equal to pi over 3. In the next video, we'll find how to determine that angle pi over 3. I'll see you then.